Warmest welcome to special guest of the day, Miss Michelle Lee, along with Miss Ellie, Miss Kelly, with our beloved lecturer Dr. Erwin, coordinators and beloved students. Welcome to today's talk on a chromatographic analysis on organic compounds and natural products presented by Miss Michelle Lee. Hereby, I would like to give a short brief on Miss Michelle Lee's background. Miss Michelle Lee graduated with a bachelor's in pharmaceutical chemistry from International Medical University. She's handling fundamental and application training for CAMAG, CAMAG, HPTLC, as well as thermo scientific FT, IR, and Raman spectroscopy. Right? Yes. Okay. She was a former chemist from a commercial lab with experience in extraction and separation of compounds from crude involving techniques such as compound extraction, TLC, CC, and HPLC. She joined Research Instruments since February 2014 as an application chemist. Besides, she is involved in testing various samples and interpreting spectra together users. Last but not least, she is familiar with CGMP, GLP, and ISO requirements. I don't understand what's all about them. Besides all this, she still never refused to say there's a long way for her to go. And I believe that too, ma'am. So without further ado, with much honor, let us put our hands together and welcome our dearest Miss Michelle on the stage. Welcome, Miss.
Hello. Alright, good. Afternoon. Thank you very much for the opening stage. Alright. So first and foremost, I would like to thank MSU for organizing this talk session and then inviting me here. Alright. So my name is Michelle. I'm the application chemist from Research Instruments. So actually looking at this venue, it makes me think back my uni time when I'm one of the persons that's sitting there as well. So the chair is really comfortable, the lighting is really warm and dim and really good to fall into sleep, but I hope that you all will stay awake for today, alright? Okay, so for today's, my topic is mainly about the thin layer chromatography techniques. So for most of the people might still think that thin layer chromatography technique is still a very manual technique, and then it needs a lot of tedious sample preparation, and at the end of the day, the result might not be very reproducible and very difficult to do documentations. So today my topic is going to share with you that how today's people actually do TLC with the current technology, which is using the instrumentation. Alright? Okay. So before I go into the more deep kind of instrumentation, just to share with you some of the definitions regarding chromatography. So first of all, what is all about HPTLC? What does it mean? So the very basic one, let's just talk about the planar chromatography first. Because chromatography is actually quite a huge group. There's a various of different chromatography. And planar chromatography is actually talking about the stationary phase is actually on a planar form. Because in TLC, the stationary phase is actually planar. If you compare to like column chromatography, your stationary phase is actually in a column form. So it's all about the stationary phase, how it looks like. So in planar chromatography, so it's actually based on a flat surface. Alright? And then the next thing is what it means by thin layer chromatography. So I'm not sure whether have you all done TLC before or not, but if let's say you have did TLC before, the stationary phase is generally like a silica plate, alright? And then we have different kind of silica plate. The most basic one is like the aluminium silica plate. So how it looks like is actually you have the aluminium as the support, and then on top of the aluminium you actually have a very thin layer of silica layer. Okay, so that what means by thin layer chromatography is that your stationary phase, which is the silica, is actually coated onto a planar support. The support could be aluminium, it could be glass, and so on. Alright? So that's what it means by thin layer chromatography. And last but not least, HPTLC. Simply means high performance thin layer chromatography. So how does it make it so high performance? It's generally in HPTLC, we are going to conduct the experiments using the instrumentation rather than our manual hand applications. Because on a manual TLC, you use hand application, there is a lot of human error that you can't avoid. Alright, later I'll share with you on how to perform manual one, and then in comparison, how an instrumentation actually able to help you to get a better result. So of course, using the instrumentations, the methodology, you can actually standardize it, and as well you can actually validate the method. But on the manual TLC, of course, you couldn't do that. So the next thing is, what is chromatography all about? So a very basic definition is chromatography is like separation. Okay, chromatography is actually to separate components, a mixture of components. So to describe to you what it means, how a thin layer chromatography works, you can actually imagine this scenario. I want to categorize a big group of people into subgroup depending on their interest. So each of them is sit inside a boat, and then you will have this river current which is flowing through the towards the finish line. So on the journey, there's a lot of river banks over here where maybe they have a lot of food sales of drinks that each and every participant can actually stop by at the river bank as long as they want. They want to eat as much as they want also possible. So I give them 30 minutes time. At 30 minutes time, I'm going to record down each and every person's position, whether are they nearby the food stall or maybe are they hitting the finish line. So after 30 minutes, what kind of scenario I will look at? Some people might be too hungry and they might just went to one of the river banks and then just feast there, not going towards the finish line. Some people might have a very small appetite, they took some food and then continue the journey towards the finish line. And some people maybe they are fasting, they have no interest in food and just travel straight away to the finish line. So this is actually what's the separation that's going to occur in thin layer chromatography. So in thin layer chromatography, you have the stationary phase, which is the silica, and then you are going to spot your sample. Let me show you. Alright. Just for example, this is actually your silica plate, which is your stationary phase. And then we are going to spot our sample at the bottom over here. Your sample could be a mixture of components. Alright? So once you have spot your sample onto the stationary phase, this plate will be placed into a mobile phase system, which is your solvent. Alright? And then the mobile phase is going to migrate through the plates until a certain level. Okay, so depending on your sample, the component. If let's say the component has higher affinity towards the stationary phase, they will tend to migrate at a lower distance. But if let's say your component have higher affinity towards the mobile phase, it will actually follow the mobile phase go up to a higher level. Alright, so it's all about sorry, the screen is a bit too near. It's all about your mixture depending on whether they are attracted to the stationary phase or the mobile phase. So that will be actually the separation that's occurring. So just into a little bit more detail, your stationary phase, the silica, is actually a polar compound, and then usually the mobile phase will be a non-polar. So depending on your component, if let's say your component is polar, it will retain at the silica plate. If let's say your component is non-polar, it will migrate with the mobile phase. Alright? So in TLC, generally the main parameter that we look at is actually what we call as the RF value. Some people term it as retardation factor, some people term it as retention time. Alright, but it's actually I think it's the same. So how do you calculate this RF value is that this is a plate. This bottom line is actually where you spot your sample. Alright? And then let's say I give a migration distance. I let the mobile phase to migrate, let's say like 7 cm. Okay? So your RF value is generally the distance of your sample travel divided by distance of the mobile phase travel. So that is actually your retention factor, RF value. So that is the main parameter in the TLC techniques. Okay, so this is just to show you some of the conventional way to perform the TLC method. I did this during, I'm back in uni, maybe like, I can't remember, maybe 3-4 years ago, something like that. So I'm not sure how you do your TLC over here. So this is a very manual way to how you perform it. First of all, you will have your silica plate, your stationary phase, and then you need to draw the template. Why you need to draw this starting line is because you are going to use it to calculate your RF value. That's why you actually need to draw the template. And then after you draw it, you use a capillary glass to apply your samples. Alright, like you apply over here. So you need to be really careful because if let's say you didn't control it, you will end up with a really large spot. And a very large spot is not going to give you a very good resolution. So people is really cautioned on this part to make sure that you try to make the spot as small as possible. And then after that, you have stored your sample. You're going to place into a chamber with the solvent in it. Alright, so by the time you place the plate into this chamber with the solvent, you're all going to sit in front of this chamber and then wait until the solvent front reach the distance that you want. Yeah, so this is what I did. You all just sit in front, just wait, looking at it. Because we don't want to overdevelop our plate. If let's say we went somewhere and then the solvent front just go up, all the way up, and then all your compound might be just out of the plate. Alright, so it actually requires some monitoring on this. And then, let's say after my grade like 7 p.m., you're going to remove it, and then you draw your solvent front. So it's actually to calculate the RF value as well. So, because most of the time, let's say like natural products or most of the sample actually is colorless in white light. So even after you have developed your plate, you actually can't see anything unless your sample contains some dye or pigments. Only you can see. Alright. So in order to visualize your sample, you will need to place into the UV cabinets. Alright. So usually the UV cabinet is like 254 wavelength. So when you place the plate into the UV cabinet, your plate will appear to be green in color. The reason is because the coating of the plate is actually will fluoresce under the wavelength of 254. So under the 254, you are able to see your compound, your components over here. Alright, but in order to document this, you can't be just take out from the white light. If you take out towards the white light, you can't see anything. So you might need to take a pencil and then just draw it. At least you know where's the position. Okay. So once you draw it, you remove it. You have the points, and then you can calculate your RF value. So this is how a manual way to do the TLC technique. Anyone did this before? Yes. Oh, no and yes. Alright. So those yes, I think you agree, right, on this kind of procedure, on the tedious monitoring. Okay? So just the concept is that you need to have a very careful sample loading and then constant monitoring and the tedious way in the documentations. Alright, so before going into the instrumentation, just share with you some of the applications for TLC. So TLC can actually find in many various kinds of applications, and actually in Malaysia they are doing really good in like those botanical samples, herbal drugs, natural products. Alright, and besides that, in pharmaceutical wise, they actually use TLC for monitoring drug stability as well as those impurities in their products. And even in the industrial, they actually use TLC to monitor their chemical reactions at each and every stage. Alright. So what I will share with you is, because you know that outside there's a lot of different kind of chromatography techniques like HPLC or CC. But what I will share with you is that actually HPTLC can actually do similar kind of application as well. And the most important thing is that actually they are operating at a much more lower operating cost compared to the other techniques. So therefore, there are various kind of manufacturers, right? The big manufacturers, they actually use TLC to do their routine QC control on their product because of the lower cost, right? And as well as there are much more flexible methods, mainly because during the method development, you in order to get a good separation of your product, you always need to play around with the mobile phase. And because in TLA chromatography, their stationary phase is one-time use. So you have less restriction towards the mobile phase that you can use, because if you use like HPLC, the column is actually reusable, it's really expensive. You can't simply just try with what kind of acid or solvent with it. Alright, so it's much more flexible techniques. And last but not least, HPTLC is really good where the applications requires it provides a visual impression, okay, which some other chromatography technique couldn't give this kind of visual impression. So what does it mean by visual impressions? So in the chemical identification of natural products, there's this so-called chromatographic fingerprint can be generated. This is what we call as the fingerprint. It's actually a type of sequence or pattern for a certain plant material. Alright? So if you look at the paprika, this is actually a paprika sample, and then this is actually a red pepper sample. Perhaps by one glance, you can actually quite differentiate their fingerprint. Okay, I'm not sure whether you can or not. But if you look at this paprika, you actually have this very intense orange band, alright, which is absent in the red pepper. So you can actually slightly see the trends and categorize your sample plant. Alright, but of course within the same paprika, different kind of paprikas, you might see that it's very slight minor differences, but this is something that we can't control, because especially natural products, depending on where you harvest from, different geographical factor is going to definitely give you some impurities on this. Alright, but somehow we're still able to look into the fingerprints. Okay, so one of the way to for identifications is by comparing the fingerprint, because I believe there's something called as the herbal product monograph. It's actually a published document where they actually have the fingerprint for some of the plant material. So when you run your plant material, you can always compare this fingerprint to categorize your plant material. Another way for the identification is that, let's say this is my plant sample from track 3 onwards, this is my plant sample, and let's say that in this plant sample, what is my component of interest is vitacin and isovitacin. This is the two of my interest. So I go and purchase the standard, and then I run on the same plate. This is the vitacin standard, and then this is the isovitacin standard. And then I run on the same plate, so I can see that whether my sample is actually having that band or absence. From there, I can know that my plant sample is whether having or not having the compound of my interest. So it's either comparing to a fingerprint or comparing to a non-standards. Okay? So, the chin layer, of course, the visualization, and then it's a very rapid technique. The reason is because in one plate, you can spot like maybe up to 12 to 15 samples. And then with one development, you can have the results for all. But if you compare to other techniques like HPLC, it's actually injection by injections. So one injection, one sample, it might take you already 20 minutes. Okay, so this is a much more rapid techniques. And lower cost is mainly because of the lower solvent consumption. Okay. So this is an example of thin layer chromatography results using a manual techniques. So in your opinion, do you think this is a good result? No? No one say yes? You all have very high standards. Okay, so this kind of result, let's say I submit this to the regulatory people. There is, I would say, very depending on the regulatory people to accept it or not, because somehow it doesn't really look that satisfying. But how about this? Yes? Way more better? Alright, so these two is actually the same samples, but it's just that one of it they are using the manual way, and then this is actually the matter transfer, they go and use the instrumentations. So this is the difference that you actually can see. Okay, so of course by this one is actually much more acceptable by the regulatory bodies. So the next slide about this one, this is just to share with you the different kind of TLC plates that's available. You still remember your stationary phase, which is a plate. So if you were to purchase a plate, there's actually different kind of plates. We have the TLC plate and then the HPTLC plates. Alright, so there are actually some certain differences. For a TLC plate, the size are usually 20 times 20, width to the height, alright? And then with this kind of plate size, the migration distance, which means that how far you want to do the development, is usually about 12 cm. And then on the solvent amount that you need to develop one plate, if let's say you use a flat bottom chamber, it actually requires about 100 ml. But this 35 ml is because our chamber is slightly different design, which I'll share with you later on. So it actually reduces the solvent consumption, and then usually one plate development is about half an hour. Okay, so this is the common TLC plates. So what's the difference to a HPTLC plate? The HP, as I mentioned, is high performance. So we have this kind of plate, we actually thanks to the plate manufacturers because they actually incorporate some of the technology to improve the plate performance. So what is the difference is generally on the particle size of the silica. They try to make the particle size much more smaller, it's about 5 to 7 micron. And then the second thing is that they narrow down the particle size distribution, which means that it's more uniform across the whole plate. So because of this, it's actually improved the plate performance, and then your separation also able to get a higher resolutions. Therefore, if you go to purchase a HPTLC plates, the plate size, the height, usually you won't get to see 20 cm. Usually it's about 10 cm because you doesn't need to travel that much to separate out your component. Usually 7 cm migration will be sufficient enough. So this is how the resolution difference. You doesn't need to travel all the way to 12 cm, but even 7 cm you already have very good separation with this kind of plates. Alright? And then of course it will reduce the solvent consumption and the running time because of the smaller plate size. So this slide also is an extension on the comparison of TLC and HPTLC plate, just to share with you on the maximum number of samples. So for a typical plate, it's usually about 12-15 samples. And then for the HPTLC, just to share with you something really interesting over here, we can actually have 72 samples on the plate. So you might actually question how it works. Let me get some props. So usually for TLC plates, right, we only spot at the bottom and then do the development, okay? But how does this 72 samples happens is actually what we're going to do is that we are going to spot at the bottom as well as spot at the top. And then instead of this vertical development, the plate is going to place horizontal, and then there will be a two-way development occur simultaneously from both sides. So therefore you can actually accommodate more samples. Okay, so this is just one of the chamber, development chamber that we have. Okay, then another kind of applications, just to show you, this is actually on the green tea samples from 3 different countries. We have from the China, and then from the Japan, and then from the India. So perhaps you already can know the different fingerprints, right? You can identify different fingerprints. For example, from the India one, you have this really intense blue fluorescence band, which the others doesn't have, and then from the Japan you actually have this really orange band, which the others doesn't have as well. So you can actually see the different fingerprints. So if any one of you are able to spot this out, this looks a bit mixed up from the balance. So this track is actually just a mix up from the Japan one. So if anyone spot out this, means that they know how to look at fingerprints. Alright. Okay, so and actually got one very important thing just to share with you is that if you look at these 3 plates, right, their first track over here, you can see that they are quite identical. So what are these? So this one, this track is actually what we call as, they are actually standard reference. Okay, standard reference. So this standard reference, it doesn't need to be related to your sample compound at all. So why do I play this standard reference at these 3 plates is because after I develop this 3 plate, I actually want to compare the result between the plates. But how do I know that whether the plates result is it comparable? Okay, if let's say I use the same method, I use instrumentation, supposedly the reproducibility is really good. But how do I confirm that? How do I tell people that it's very reproducible? Because they are actually different samples. Okay, so that's why I actually place this kind of standard reference. This 3-track is the same standard reference. So if let's say I run the plate using the same method and then using instrumentation, this 3 standard, the RF value will not deviate that much. Okay, it should be about there because they are the same standard reference. Okay, so if let's say the RF value is within your acceptance criteria, so let's say it should not deviate more than 0.02 or something like that, that means that your result is comparable. Okay, so this is what we actually call as a system suitability test. Okay. So just to share with you a typical application in the herbal analysis. So why HPTLC is really good for natural products and botanical samples? So I would say mainly the reason is because these are natural products. First of all, there are a lot of components inside. Okay, there are a lot of components inside, as well as the second thing is that most of the component is unknown to you as well. So if let's say you use this kind of natural product, you go for HPLC, you have a lot of peaks, and then because those things is unknown to you, it doesn't have any standard as well. So the bunch of peaks, it actually doesn't give you any meanings. Okay, but if let's say this sample, the very same sample, you run a HPTLC, at least it gives you a fingerprint. Okay, and then you can actually match it to some reference fingerprint. Okay, so that's the reason why HPTLC is really good in the natural products, because it's actually a really complicated compound. Okay, and then this is just to show you, as I mentioned, the monograph. So actually this monograph is like a document, like some of the plant material they already share with you, how does the fingerprint looks like and all the informations. So it's just a comparison, as I mentioned. Let's say your sample fingerprint, you can actually compare to the reference, or you can actually compare to the standards that you are looking at. Okay, so besides of that, HPTLC also mainly used in the product development, especially like the pharmaceutical company. They develop their products from the plant material. So of course, during the method development, you will come across like the extraction steps. Okay, so what this is actually the first track, and I'm sorry if the color doesn't appear too good over here. So the first track and the fourth track is actually standards, and then the 2 and 3 is actually from ethanol extraction. RM is actually raw material, and HMP is actually their products. So this 2 is actually from the ethanol extraction, and then 5 and 6 is actually from the isopropanol extractions. So different way of extraction definitely is going to extract different kind of components. So they also use this TLC to monitor whether the extraction process is able to extract what they want. Okay, so this is a kind of application as well. And last but not least, in process control. So for example, like the first one is actually the raw material fingerprint. The second is the extract. The third is the finished product. So they want to know that at each and every step, whether do they lost some component or whether is some component being decomposed or anyhow. So they want to ensure the consistency of the product quality at each and every stages. So these are some of the applications of it. Okay, so just now I talked about all the fingerprint. So the fingerprint is actually a kind of qualitative analysis. Okay, qualitative. Actually nowadays TLC can also do quantitative, which means that the sample, the component is already known to you. You already identify it, but the next step is that you want to quantify it. You want to know what's the concentration. So TLC can do that as well. Okay, so how do you do that is that we will actually use one of the instruments which is actually a densitometer. So the densitometer will actually generate you some of the chromatogram. Alright, it's something similar like what you see in HPLC. So the peaks, you actually have the peaks for the components. So of course, higher concentration, the peak will appear to be higher as well. So you can actually do the quantification based on peak height or peak area. Alright, And then this one is another application which is for the quantitative analysis. So this is actually on an adulteration test. They actually this raw material, this herbal drug is actually called as Staphyna tetranda. This Staphyna tetranda actually they got a lot of herbal advantage uses, means that they can actually very therapeutic, they can treat a lot of disease. But what do those people do is that they try to substitute this plant with another species and sell it at the same price. Okay, so this is what we call as the adulterated one. So unfortunately, if let's say the plant that they use to substitute is non-toxic, then it's okay, alright. But what if let's say that the plant that they use to substitute is toxic, then it's bad for us. So this is an example where they substitute the species with another species which has the aristosic acid. So this aristosic acid is actually really toxic and will cause renal failure. So the FDA actually uses this thin layer chromatography to look into it. So the first true track is actually the pure Staphyna tetranda, alright, which only have the blue band. And then the third and the fourth is actually the adulterated one, the one that they choose to substitute the original. So their fingerprint is actually very similar to the Staphyna tetranda, but they're actually having additional green band there. So you can actually identify, and this green band is actually the aristosic acid. Okay, so they just run together with all these aristosic standards in order to quantify the toxic compound in the sample. Okay, so next thing is that, as I mentioned, okay, this is actually an example that two labs, they are running the samples, peppermint oil and spearmint oil. So the two different labs, they are running individually using the same method, but somehow the result is actually not very comparable. Okay, the reason is because, as I mentioned, manual TLC techniques will actually introduce a lot of human errors. So that's actually something that you can't control. Alright. So in order to get a better result, of course, you will need a method. That is for sure, you need a method, and then you will need the plates. And last but not least is the instrumentations that going to help you. So using instrumentation, less human error, and therefore your result will be more reproducible. Okay, so before I go into the instrumentation, just to share with you the steps in TLC, which I think I already gone through just now. First of all, which is on your sample applications. After application, you got to place into the chamber for the developments. So after development, derivatization is actually very depending on methods, because as I mentioned just now, the plate, after you develop, you actually can't see under white light. You need to put into the UV cabinet. But sometimes you can actually spray with a certain reagents that it will have some chemical interaction with your sample, and therefore your sample from colorless will turn to some color. So that's what the derivatization techniques. And then next one, we will move into the detection, whether you want to do a qualitative or quantitative, and last but not least, documents your result. Okay, so before I go into the instrumentation, just to share with you, the instrumentation is actually under the brand Chemac. It's actually a Switzerland brand. So they actually develop their own instruments and software as well. So I would say TLC is a very flexible technique, okay? So this is actually the series of the instruments that helps you to do it. So the first one, which is actually to apply your sample, okay, it's an auto sampler to apply your sample. Then after that, you will go for the developments, and then scanner if let's say you want to do quantitative, and visualizer to capture the image. So you doesn't need to be doing it all at the same time. Let's say you only want to get the visualizer, you can do everything manually and then place the plate into a visualizer to use it. Or let's say you feel that sample application is the most important, you can get this one to help you to do a sample application, and then you can do a manual development. So it's actually really flexible on this one, okay? So this is just to share with you on the software, but at the end I'll have a video to share with you, so I'll just skip this. So first thing on the sample application. During when you are doing sample application, there's a lot of things, there are a few things that you actually want to achieve. The first thing is that you want to make sure that your sample application point is always at the same point. The second is make sure you have the smallest spot as possible, alright? And then reproducible volume. which is very important if you want to do quantitative. Okay, so of course this, if you let's say use a manual way, of course this is something that you can't control, but the instrumentation will help you to solve this. So on our instrumentation, for the sample application, we actually have 3 kinds. Nanomat is actually a very basic one. It's a manual kind. You have a ruler that guides you. Nanomat is a semi-auto. What you need to do is that you have to manually do the sampling with the syringe. Place the syringe here, and then it will automatically apply onto your plate. So this is semi-auto. And the last one, which is our ATS4, is actually a fully automated sampling applications. So I'll go for later I'll brief more on this one. So during the sample application using our instrumentations, you can actually choose to apply your sample in 2 kind of forms. Okay, we have the contact, which is the round form usually you see, and then there is another one which is actually called as the band form. If you realize just now, all the fingerprints that I show you is actually appear to be in a band form rather than a circular. Alright? So actually a band form gives you a better resolutions. The reasons why is this is actually an example of the test dye. Alright? And then the test dye is dissolved in different kind of diluent. N-hexane, toluene, and methanol. Okay? If you use the contact, like what you did in the manual, you contact, no matter how cautious you are, you actually can't avoid how the spot diffuse because it's depending on the diluent. For example, if you compare hexane to water, of course the water is going to diffuse into a bigger circular. So therefore, this is something that you can't control, like for example methanol. When the spot is too big, the resolution is not that good. But on the band form, so how does this band form does is that it actually does not contact on your plate. It's actually, your sample is going to be sprayed onto your plates using a nitrogen gas. So it's a non-contact application. Therefore, no matter what kind of diluent that you use, you can still get a really precise band size. It will not be diffused out because it's a non-contact. Okay? So this is the example of the ATS4, which is a fully automated one. So this is actually where you place your sample vials, alright? And then this is your plate. So what it does is that there will be a syringe here. It will automatically withdraw your sample, go to your plate and do the applications. And then once it's done, it will do the auto rinsing. So everything is automated. All you need to do is just to place your sample here, you place your plate here, and then just configure a little bit on the software. You click start, everything will be done automatically. Okay? So I have a video to show you on how the spraying does.
CAMAG is the world leader in planar chromatography and provides instruments, software and consumables for all steps of the TLC-HPTLC procedure. The automatic TLC sampler ATS4 allows for fully automatic sample application and is suitable for high sample throughput in routine work. The instrument is software controlled and enables precise and reliable application of samples. The dialog box for instrument parameters offers user-friendly default settings. However, if you need to change predefined parameters, for example for quantitative analysis or for application of an aqueous solution, you can do this by just a few clicks. When working with default settings, it is only necessary to fill out the sequence table. The sequence table contains all the information which is needed to automatically run a series of samples. With its guided approach, the VisionCat's HPTLC software effectively leads you through the entire chromatographic process, step by step. Position the TLC-HPTLC plate on the self-adjusting object support. After having loaded the ATS4, you can start the fully automatic sample application. VisionCat displays the current status of the sample application and the expected end time. An application sequence starts by rinsing the syringe. Next, the septum is punched and the needle lowered into the sample vial, thus allowing the syringe to be filled with the sample solution. The septum punch is retracted prior to the needle being removed to ensure the outside of the needle is wiped off by the tightly closing septum. The syringe moves to the programmed position of the plate and starts applying the desired sample volume. Several applications of the same sample are applied in sequence. Samples are applied as bands by default. Spots and rectangles can be applied as well. After the final application of the sample, the syringe is emptied into the waste and rinsed again, ready for the next application sequence. Once all samples are applied successfully, just open the cover and remove the applied HPTLC plate for chromatogram development, the next step of the HPTLC process.
Okay, so that's how you see the sample application which is being sprayed on it, alright? So after your sample application, we'll move on to the development parts. So this chamber is actually like the manual one like you have in the lab. So you just place your plate and then you monitor yourself. So over here, there's actually, instead of the flat bottom, this is actually called as a twin trough chamber. So the bottom, instead of being flat, there's actually like two drains over there. So because of the design, it actually reduces the solvent consumption. Okay? And then this is the one that I mentioned, the horizontal development that actually can give you a result up to 72 samples because the plate is lie flat and then developed from both ends. So this is the horizontal one. And then generally people who get this one, this is actually the automatic development chamber, ADC2, which is for a isocratic developments. So isocratic means that during the whole development, your solvent composition remains the same. It does not change. Okay? So this is for the isocratic. And then, actually nowadays, TLC can also do gradient analysis, gradient developments. So gradient, which means that across the development, you want to change the solvent composition. So we can actually do that as well, which is AMD2. So before I move on to how the ADC2 works, just to share with you, during your development, your chamber condition can be a different kind of conditions, alright? So first of all, the first kind of condition, we call it as the unsaturated conditions. So how does this do is that your chamber, you pour in your mobile phase, you straight away put in your plate, you close it, and then start development. So that is what we call as the unsaturated one. The second one is saturated with filter paper. So how does this do? Difference is that your chamber, pour in the mobile phase, close the lid and let it to saturate for maybe like half an hour. This is actually to ensure that your whole chamber is saturated with the solvent vapor phase. Okay? So once half an hour done, you open the lid, only you place in the plate and then start development. Okay, so that was the second condition. And the last condition is that saturated and precondition. This one is that you place in the solvent, you close and wait for half an hour. After that you open, you place the plate in but not touching the solvent yet. You want to expose your plate to the vapor phase. So that is what we call as the plate preconditioning. Maybe you expose for 1 minute, only you dip your plate onto it and start the development. So this is the three kind of possible condition, but there is actually no wrong or right because different kind of condition is going to give you different kind of results, different kind of separations. So it's actually very dependent on the method. Okay, so this is our ADC2. How it works is that I'll have a video to show you as well, just to share with you. First of all, you actually need to place your plates over here and then your solvent on top of these two funnels. So you have to configure onto your system, on the software, you have to tell the software what is your migration distance that you want, how far you want to develop, let's say 7 cm. Okay, you develop that, and then you tell them what kind of chamber condition you want. Let's say I want to saturate for 30 minutes. So you tell the software, and then you place the plate, you put in solvent, you click start, you can go for a break, and then you come back. So everything will be automated. So once you click start, what it does is that, let's say I want the saturation. So first of all, only the solvent will enter this chamber, and then you will wait for 30 minutes. Once 30 minutes done, the plate from this part will actually automatically go down to the chamber and then start the development. So during the development, we will actually have a sensor over here to sense where is your solvent from. So if let's say your solvent from migrate until 7 cm, the sensor sees it, your plate will be automatically lift up back to this compartment for drying. So everything is automatic. You doesn't need to sit in front of it and monitor the progress. You can just go out for a break and then come back, get your plate from the top. Okay? So another short video for you.
CAMAG is the world leader in planar chromatography and provides instruments, software and consumables for all steps of the TLC-HPTLC procedure. Chromatogram development is the heart of the HPTLC process. In the CAMAG Automatic Development Chamber ADC2, this step is fully automated and reproducible, independent of environmental effects. The activation of the plate, preconditioning, chamber saturation, developing distance, and final drying can be preset and monitored using the VisionCat's HPTLC software. With its guided approach, VisionCat's effectively leads you through the entire chromatographic process, step by step. The ADC2 will automatically develop the plate, leaving the analyst free to do other work. The ADC2 provides development under controlled conditions. Open the front door, load the applied plate in the plate holder and insert the plate into the automatic developing chamber. Pour in 10 milliliters of the developing solvent for plate development and 25 milliliters of developing solvent for chamber saturation into the solvent ports. The entire process is monitored. The plate is developed in a saturated chamber if using the default settings. The automatic developing chamber ADC2 and the optional humidity control create standardized conditions, obtaining reproducible results from plate to plate. Perform chromatography under different climatic conditions and compare chromatograms created in different labs of results obtained from different batches. Chromatography is started by lowering the plate into the developing solvent. During chromatography, the position of the solvent front is monitored. At the end, the developed plate is homogeneously dried in an airstream. All parameters are recorded in compliance with CGMP/CGLP as part of the analysis. After successful chromatogram development, just open the front door of the ADC2 and remove the developed plate for the next step of the HPTLC process.
Okay, so that's how the ADC works, alright? So just now if you realize over there there's actually a humidity control chamber. So just to share with you that actually the humidity will also affect your separations. So for example, this is actually a test die. The same test die but run under different kind of humidity. So 17, 47, 75, so you can see the different kind of separations, okay? So if you use ADC2, you can also control the humidity as well. So I'll just quickly go through this one. Just now that one, the ADC2 is actually an isocratic development. So this one is actually for the gradient development. So what's the principle behind this is that, let's say, first of all, I want to develop the plate with, let's say, 100% of methanol. So it will actually develop until a certain distance that I want, and then move on to the next step. Sorry. Let's say the next step is 80% methanol, 20% DCM, and then it will start to develop again, and then change the composition and develop again, and keep on repeatedly develop your plates at a different condition. So this is how the gradient actually works. So on the software, it's actually really easy. What you need to do is just to tell them what is the solvent that you're using and what is the percentage that you want to go for. Like over here, 100%, I want to develop for 10 mm. The next step is 85%, I want to develop 13 mm. So this is all the parameters you just need to set in, and then everything will be done automatically. So this is actually the gradient illusion. So gradient illusions people use is because of the gradient analysis is able to separate more components compared to the isocratic one. Alright, so after development, the next step is, as I mentioned, this derivatization is very dependent on method. Some method needs it, some method do not need it. So if let's say a manual way, let's say usually our derivatization is by using a spray to spray on the plates, but sometimes spraying, it might not get a very uniform spraying. Sometimes maybe you only spray this part and then that part is empty or something like that. So instead of using a spraying, you also can, we have this which is called as the immersion device. So the reagent is being filled up in this chamber, and then when we click start, this plate will automatically dip into the reagent and remove back up. So it's actually a more uniform coating of the reagents. Okay, so this is a dipping technique rather than the spraying technique. Okay. Alright, last but not least, we come to the chromatograph evaluation, which means that at the end we get our plates. How are we going to analyze the result? What's the result that we can get? So of course, a very easy way to look into the result, which is using a UV cabinets. Okay, so this UV cabinets will have different light source. So have 254 and 366. So dependent on what kind of component, it will actually absorb at different wavelengths. So this is the UV cabinets. And this is actually another system which we call as the visualizer. So this visualizer, we have 3 light source, white light, 254 and 366. So on top here, there's actually a camera for you to capture the image as well. I mean, it will auto capture. You don't need to use your phone to capture it, okay? So you actually get the image. And what's something good about this visualizer is that through this image that you capture, from this image, you can actually generate the chromatogram. What it means by chromatogram, for example, let's say this track, I have 3 bands. So the chromatogram will appear like this. The chromatogram, y-axis is the absorbance unit, x is actually the RF value. So of course 0, which is the sample application point, there will be some response. And then the blue band will be this one, the red one, and then the last is the yellow one. So from this chromatogram, we can actually do the quantitative analysis. Okay? And through our software, we actually have this really good image comparison, is because especially when you want to compare results from different plates, all you do is just that you place the 2 plates together and then just look to see whether it is similar or not. But through the software, you can actually extract the individual band from different plates and place side by side for the evaluations. So this is a comparison features from the software, which is really good for batch-to-batch analysis. And the last one is actually our scanner. So if you still remember just now the visualizer, you can capture the white light, 254 and 366. But let's say your component do not absorb at this wavelength. So you actually need to go for a scanner, because the scanner you actually have a larger range, which is 190 up to 900 wavelength. So some component maybe only absorb at 500. So you actually get the scanner to get the chromatograph. So the scanner main objective is actually to get the chromatograph in order to do the quantification. And then just to share with you the scanner, we can actually scan up to 31 different kind of wavelengths. So it's just to key in here. So this is the application where they actually do the quantification. So you have the samples, and then of course you will need the standards. So we will just place this plate into the scanner in order to scan the chromatogram. Okay, so this is how the chromatogram will look like. So as I mentioned, the peak, if let's say higher concentration, the peak will appear to be higher absorbance value. So you can actually choose to quantify based on peak height or peak area. Okay, so the software will actually generate you the calibration curve in order to quantify your sample. So beside of the scanner, besides can get the chromatograph for quantification, it actually can also scan spectrum. So what spectrum means is that, let's say because different component, right, could actually have the same RF value. Alright, so if let's say I have the component, the two components is same RF value, but I'm not sure whether are they really the same component or not. So what I can do is that I scan a spectrum for the two components. If let's say the two components is different, their spectrum will appear different. So this is like the second stage of confirmation. Because the first stage of confirmation is the RF value. Alright? Different RF value, definitely different component. But same RF value doesn't mean they are the same component. So this is the second step to further identify them. Alright, then after you collected the spectrum, you can also build your own library for future search. So this is heading towards the end already. I hope you're still awake. Alright, so just to share with you with our software, there's actually some method library because the Chemex in Switzerland, they actually have already tested various kind of natural products. So they actually have some of the methods. So for example, like over here, you have the different Latin name of the samples, and then you actually can click download on their method. When you download their method, what kind of information that you can get? First of all, of course, is their documents on how do they perform this test. What kind of mobile phase, how they do the sample preparation, all the information is there. And then of course you will get the method file in order to run with our software as well. Last but not least, they also provide their plant fingerprint. So if let's say you are running the similar kind of plant, you can always compare the fingerprints. Alright, so just to share with you, if any one of you are actually doing TLC, you can actually go to this website. This is actually a public website. All you just need to do is to sign in, register. You don't need to pay anything. And you can actually download some methods from there as well. Okay? So what you will get is as well as all the documents and how to prepare your samples. Okay? So last but not least, just to share with you the last video, which is actually on our HPTLC Vision Cat software. So the software actually called as Vision Cats.
HPTLC analysis made easy using Camag's Vision Cat software. Vision Cat's HPTLC software stands for intuitive simplicity and takes high-performance thin-layer chromatography to the next level. With Vision Cats, you can organize the workflow of HPTLC, control your involved Camag instruments, and manage your data. The easy-to-navigate user interface effectively guides you through the entire HPTLC process, from definition of samples and substances to reporting of results. Creating your own method has never been easier. Simply define the desired analytical steps, or select one of the default methods and start working. Vision Cats will guide you through the process. A precise sample application is a crucial factor for the quality of the HPTLC analysis and the results obtained. Using Vision Cats together with the ATS-4, a fully automated sample application for routine use and high sample throughput is supported. Plate development under controlled conditions is a key to reproducible separations. With the fully automatic developing chamber ADC2, you always obtain the same RF values of your compounds, independent of environmental effects. Controlled by Vision Cats, the TLC visualizer can generate low-noise, high dynamic range images. With the image comparison viewer, tracks originating from the same or different plates and detection modes can be compared on the same screen, side by side, and as many as you need. The new sample-oriented approach allows for creating virtual plates from tracks originating from different plates for batch-to-batch comparison or long-term stability testing. VisionCats controls the TLC scanner and enables quantitative evaluation of the generated densitometric data. Easily perform substance assignment of each separated compound at its optimum wavelength. Choose the best fitting calibration model for evaluation and quantify via peak height or area. After your HPTLC evaluation, simply export your report as a PDF, Word, or Excel file. As a licensed VisionCats user, you can download validated methods from the HPTLC method library free of charge and import them into your own VisionCats database. Each method includes 3 files: an instrument method ready to use in VisionCats, a method document that you can use to create your own SOP, and an image comparison file including reference images. HPTLC analysis made easy using Camag's VisionCats software, made in Switzerland.
Okay, so that is actually the end of the presentations. So I'm going to have some question and answer session just to make sure that you all didn't fall asleep across the session. Now I got some freebies to give as well. Alright, so the first question is, what's the 3 light source that is being used in visualizer? Anyone? The 3 light source in the visualizer.
White light 254366.
Yeah, she got it correct. Paying attention. So for the ATS4, the sample application, the automated sample application, during sample application, you can actually apply your sample in 2 forms. What's the 2 form? Sorry? On the sample application, how you apply your sample onto the plate. The very first step, you apply your sample onto the plate, you can apply in 2 different kind of forms. What is the 2 forms?
The band form, and the other one is the circle form.
Yeah, contact form, yes. It seems my question is a little bit easy, is it? The next question is that give a reason why HPTLC is used for botanical products. Why people that deal with natural product, botanical products, why do they choose HPTLC? Alright, actually it's yes, so. You can maybe tell everyone.
To get the fingerprint pattern and to compare it with the monographs.
Yes, you're right. It's quite a good answer. Anyone can give one advantage of using the instrumentation compared to the manual technique?
It can run more samples up to 36 to 72.
Yep, yes. Any more advantage? That was just one of the advantages.
High performance and less error compared to manual.
Yes. Anyone want to try? There's a lot of advantage. It costs less. What is it? Costs less. Costs less. If we can think of another one, it's quite subtractive, I would say. Cost less of oil.
Less time consuming.
Less time consuming, can be as well, Actually, it's less monitoring that's required. Yeah, do you remember one of the things? The instrumentation, of course, can do quantitative analysis, which the manual ones actually couldn't. Right? Okay, so the next question: what is the software name for Chemet HPTLC? The software name.
Research Cat.
Yes. Okay, maybe I'll just ask the last questions. I actually have a nice home drive over here. What is the extra information that you will only get in T-layer chromatography that is absent in other chromatography techniques? What is the extra information that you can get?
We can get the visual images.
Yes. So that was my question and answer session. Actually, if you didn't get any gift, you can also ask me questions and I will give you gift as well. Whether I can answer or not, that is another question. Anyone have questions? I can come to you. I also have this calendar and pen holder.
How you clean the machine? Is it self-cleaning or you have to clean it by yourself?
There's a lot of instruments there, by the way. So, the cleaning, as I mentioned, there's a lot of instruments over there. Let's say for the automatic sampling, the one that do the sample application, there's actually an auto rinsing, which means that every time they apply the sample, you actually do an auto rinsing. So because there is a rinsing bottle and then a waste bottle, so you actually do the auto rinsing itself, you doesn't need to do anything. About the development chamber, that is after the development, there will be actually auto rinsing. So generally all is auto rinsing, you doesn't need to clean it. Then the visualizer, of course, you just place the plate, there's no cleaning requirement, as well as the scanner as well. Okay, so everything is auto rinsing. Alright? Any more questions?
I want to know what is the cost to set up this kind of.
What's the cost, salesperson?
Depends on which module you want to run.
Yeah, I think that one you need a private session with our salesperson in order to get a quotation, I guess. Any more questions?
Do we need to calibrate the machine, and how long it should? If yes.
All really high quality questions. So definitely all the instruments being calibrated even before they ship out from the manufacturer. And of course besides we have sales team, application team, we also have the service engineer team that will always do a yearly performance test to ensure that all the instruments is qualified. Because they have certain standards to run and make sure they actually get the achieve the requirement. So how frequent? I bet even in the industry they do it once a year, depending on how stringent is your requirement. Have I gave you this? Thank you. I got two more.
Does the way you discharge the solvent eco-friendly enough? Does it cause pollution?
Okay, so that one will be, let's say for the ATS4, the sample application. So as I mentioned, there's actually a waste bottle. So every time after they rinse the syringe, it actually goes to the waste bottle. So you actually manually take the waste bottle and then dispose the solvent itself. So that is for the sample application. Whereas for the development chamber, whatever solvent that you pour in, after the development, the solvent will remain in the chamber. So you actually need to dispose the solvent yourself as well. Alright? Yes, solution.
From the green tea slides, we want to know which green tea is the best.
Which green tea is the best? So green tea is actually used for what benefits? Antioxidant? So antioxidant. So antioxidant also got various kind of antioxidant. Which exactly antioxidant that you're looking at? So if let's say you want to say which green tea has the best quality, definitely you're going to look into the antioxidant band. And because you already specific that you already know this is the antioxidant, you can just purchase the standard and then run together with the natural product. So at least you know which band is the antioxidant. So from there you can actually do the quantification. I'm not sure is it really higher concentration means better quality. This I'm not so sure about that. But I think that's the way it is. You can actually quantify the antioxidant. Alright? Okay?
Okay, why did you choose this field, not other field in pharmaceutical?
Personalized question.
It's really a personal question. Why I chose pharmaceutical? Yeah, I think my uni actually offers pharmacy as well, but I think it's the time I have very low knowledge in what does really a pharmacy does. Because when they ask me, why did you take pharmacy? I'm imagining myself, I don't want to stand in front of the Watson counter and just dispense drug all the day. But actually pharmacy have very much more career path compared to standing at the Watson. Alright, so yeah, definitely. In the hospital, government, private, as well as in even like manufacturing, pharma manufacturing, with a license, with pharmacy license, you can always go higher compared to a one that doesn't have a license. Alright, so why I choose pharmaceutical chemistry, I think is that I have more passion in chemistry. Yeah. Alright, so I hope I answered the question.
Okay, thank you for the wonderful talk, Miss. So, we are pleased to welcome our Honorable Lecturer Dr. Erwin to the stage and present a small token of appreciation to our Honorable Speaker, Ms. Michelle Lee.
The researchers.
Okay, as saying goes, to every beginning there is an ending, and now the talk session has come to its end. Well, it has been a great day with all of you. Again, thank you for all your presence. God bless and good day to each and every one of you. And Group B, all the best for your PP1 test. Hereby I have to announce there will be another talk at 1 o'clock regarding natural products. So those who don't have any classes after this may continue here. Have a nice day and have a nice walk.